A very good morning to all the participants for our fourth day of FDP. Okay, and I'm welcoming all to the first session of the fourth day. So, as you are aware that we have already announced the slight change in the schedule of today's sessions. I am just again repeating that change. Okay, so this session will last up to 11, and from 11:15 to 12:45 the next morning session will be there. Okay, and from 12:45 to 2:30 you will be having your lunch break. Okay, so we'll be again joining in the afternoon session at 2:30 p.m. Okay, so that is the change. So now we'll start with this morning session of today. So I will introduce first our speaker. Okay, so we are today having Dr. Prashant Kumar Raut as an expert for this session. So he's principal scientist working in the phytochemistry division of CSIR lab, that is Central Institute of Medicinal and Aromatic Plants at Lucknow. So briefly, I will give introduction of the speaker. So basically, Dr. Prashant is having a chemistry background. He's holding BSc and MSc from Utkal University of Odisha, and he is having PhD from IIT Delhi. He has been working in CSIR CMAP lab since 2009. So he's also uh, received Commonwealth Fellowship and was fortunate enough to work in University of Saskatchewan in Canada during his PhD tenure. And he is a recipient of Senior Research Fellowship of CSIR in year 2003. Dr. Prashant is also credited with 8 patents in his name, out of which 3 are international patents and 5 are Indian patents. And his one technology of essential oil-based antimicrobial that is helpful in bronchospasms has already been transferred to an entrepreneur. So he's also having one technology transferred to his credit. And he's also having 55 international publications, 11 Indian journal publications, and conference proceedings, 28 international and 31 national conference proceedings, and is also having, to his credit, 4 book chapters. Now, his basic research areas includes catalytic modification of medicinal and aromatic compounds, catalytic and lipase modification of cellulosic biomass, biotransformation and catalytic transformation of fatty oils, and is also involved in green extraction processes of medicinal and aromatic plants. So we are fortunate enough to have Dr. Prashant Raut for this session. So he will be today talking on valorization of commercially important aromatic crops for fragrance and flower applications. So these are fragrance and flavor applications, as you are aware that there is a huge market for these types of compounds. So I hope this session will be of interest, particularly those who are from chemistry background plus chemical engineering background. They might find it interesting. Okay, so now I hand over the session to Dr. Raut. Okay, Dr. Raut, over to you.
Yeah, thank you, Dr. Jadeja, for very extensive introduction. I welcome all the participants and a very good morning to all. And I fortunate enough to Chemical Engineering Department of SNB, NIT, SBNIT for giving me a platform to present my work. So, so being a medicinal and aromatic plant institute, so my main focus is how to use our medicinal and aromatic plants to give some high value products. So specifically, I'm not discussing more about this medicinal chemistry. So mainly I focus how to use the essential oils which is produced by these aromatic plants to high value products or different applications which is benefit to our farmers. So in last 5 years CMAP is working extensively on cultivation of aromatic plants in farmers field. So in last 5 years, we have covered more than 10,000 hectares of land in India for production of essential oils. So now the basic question is how to give market to our farmers when this essential oil is produced in huge amount. Because once this essential oil price is very high, but due to more cultivations and due to promotion of cultivations, now these essential oils are very huge amount of produced per annum, and now farmer facing marketing challenge. And this essential oil also slowly decline the price. So for a sustainable agriculture, this farmer need the value and they need the better market for cultivation of these aromatic crops. So with this deep introduction, I start my topic today. This valorization of commercial important aromatic crops for fragrance and flower applications. So Dr. Jadeja, am I audible?
Yeah, yeah,
Okay, okay, fine.
fine.
Yeah. So first I discuss about the plant. What is the plant? So most of you people are in chemical engineering background. So in a brief introduction, what is the plants? So it is very common and very well known to everybody that plants provides us food, shelter, clothes, as well as medicines, and for our cosmetic and flower applications. So if I broadly classify this plant metabolites, so it is the primary metabolite. So primary metabolite means it produces huge amount by the plants. So it is in the form of carbohydrates, lipids, proteins, and nucleic acids. So which basically used for our food, uh, this clothes and our shelter applications. And similarly, the secondary metabolites, which is the most important, and particularly my institute is working on the secondary metabolites. So in the secondary metabolites, it is consisted of terpenoids, alkaloids, steroids, polyketides, and these are all biotic compounds which may have the application in as a drug or as a cosmetics or as a flavor and fragrance. So mainly I focus on the secondary metabolites. So then, in particular, this aromatic plants is contain the class of compounds, or it is coming under the class of compounds which is known as the terpenoids. So, what is the terpenoids? These terpenoids are hydrocarbons resulting from condensation of several type C isoprene units. Means in isoprene units, which general form this general formula is C5H8, and this isoprene units is the joined two units, three units like this, and then they form the monoterpenes, sextuterpenes, diterpenes, triterpenes like this. So according to the number of isoprene units, so it is classified. So the basic unit of these terpenoids is the isoprene unit, so which is C5 and H8. So particularly these terpenoids, if we discuss about the floral essential oil like rose, it contains geraniol and citronellal, which is the monoterpenes. Similarly, in case of lemon or orange, it contains limonene. Similarly, black pepper, major compound is beta-caryophyllene, and in case of clove, it is eugenol. So, particularly this eugenol and beta-caryophyllene, it is the sextuterpenes, but this geraniol, citronellal, and limonene is the monoterpenes. So, what is the isoprene rule? This rule was proposed by Otto Wallet in the year 887, which states that all the skeletal structure of all terpenoids are built of isoprene units. In 1925, Ingold proposed a special isoprene rule, which states that isoprene units are in terpenoids are joined by head-to-tail linkage or one-pole linkage. So, particularly if you see the first ones, so in which so it is the tail and it is the head of this isoprene unit, and here this head is connected to this tail. So accordingly, it is the general assumption that it is connected to the tail and head sections. So similarly, some of exceptions are also here. So here the compound like krypton, which having the C9 carbon chains, and here it is a closed ring structures. So here one of the carbon is oxidized to O. And similarly, in case of lavender oil, so which is open from the lavender oil. So this lavender also having the C9 carbon chains, and one of the carbon is oxidized to OH groups. So this is the common isoprene rules in which all the terpenes follow the similar fashions. Maybe a slight deviations in this rule, but most of these terpenes follow this isoprene rule. So actually, how the plant will be synthesized. So we have not discussed more about the biochemistry. So actually, the plant synthesize these molecules, the well-known path which is known as the melvanoid pathway. So by this melvanoid pathway, so it passed from the melvanolic acids. So for this melvanolic acids, the precursor is methyl erythral pathway, in which the 2-methyl d-erythral 4-phosphate is initially formed by these plants. Actually, this plant form this essential oil in a special gland. So why plant produce this essential oil? Because this essential oil is antifungal, antibacterial, and it is also not liked by the herbivorous animals. So plant produce these terpenes or store these particularly terpenes in its cells, and in leaves it form extra structure which is known as trichomes. So it accumulates in these trichomes, so to protect itself from pathogenic attack, also from the herbivorous attack. So to protect, it is just used by the plant as a plant protection reagent. So in this pathway, the plant is produced. So when plant is mature, then we'll harvest it and we extract these essential oils. Similarly, some phenyl propanol pathway also discussed. So though I am not a biochemistry, so I would not enter more depth in this discussion. So then in a common definition of essential oils are natural aromatic compounds found in the seeds, bark, stem, roots, flowers, and other plant of the parts. It gives plant to their distinctive smells and provides protection against predators and diseases. What I have discussed, it gives the plant as a protection agent. The distinctive character of an essential oil can be attributed to the functional groups. So it may be in the form of esters, ethers, aldehydes, lactones, ketones, and alcohol. So in this isoprene unit, so actually these functional groups are also attached, so that it gives the better organoleptic profiles and better fragrance profiles or better flower profiles. So only hydrocarbon structure is generally not liked by the fragrance or flower industry. These terpenes are key compounds of all essential oils. The structures of terpenes are recognized as a derivative of isoprene units already discussed, and it is joined by head to tail fashions in the common structural similarities. So first I discuss about flowers. So actually when we discuss about the fragrance, first we discuss about or something coming to our mind is flowers. So how this flower gives the fragrance, and which is very refreshing, and it gives a peculiar smell, so that we can smell these things from a few kilometers away also. So actually, for these flowers, so particularly the flowers, when we are discussing about the other aromatic crops, so mainly people use or industry use the hydrodistillation process. But this hydrodistillation process is not feasible, or it is not commercially so important in case of flowers. So already this essential oil also produced from these flowers, but the more profitable is people use the concrete. So though flowers contain very less amount of these terpenes or fragrance profiles, so the concrete is the most profitable one. So in this concrete, the fresh plant parts or flowers is deep in the hydrocarbon solvent, and this hydrocarbon solvent extracted these terpenes from these flowers, and after evaporation of this solvent or hydrocarbon solvents like hexane, pentane, heptane, or petroleum ethers, we get the semi-solid dark color materials which is known as the concrete. So actually here the drawback is when you put in the solvent, it extracted the flower compounds, but it also extracted so many other compounds which is not of our interest. So that this fragrance extracted material is semi-solid in nature. So due to this semi-solid nature, it is easily not used in the formulations, because people are using this fragrance for making formulations. When we make these formulations, this particularly waxy material is not soluble in any formulations. It may be mostly people are using water or alcohol as a solvents for using these healthcare products, because organic solvents are not allowed. So for that, it is not generally soluble in alcohol and water. So though it is the most commercial form of these flowers, but it has some drawbacks. And in the case of flowers, when you will go for hydrodistillation, it gives very less amount of essential oil, and due to this very high sensitive terpenes or which are very heat or thermolabile compounds, sometimes this original fragrance is little bit changed when you go for hydrodistillations, because in hydrodistillations this flower is distilled in hot waters for 5 to 6 hours. So in this process, due to this water and this heat, so these hot and humid conditions facilitate the terpenes to change to their nearby structure. So it is not truly represent what is present in the flowers. So that to overcome this limitation, this liquid carbon dioxide is most more profitable one, and it is selectively extract the terpenes. So here in this carbon dioxide extract, it is also working at a very room temperatures or around 10 degrees centigrade. So and when you release the pressures, all the carbon dioxide will be released. So this is a very profitable process and very thermally important process for extracting the floral volatiles, because this cost of this floral volatiles is very high. So for this, just I give a comparison. So how will benchmark the different extracts? Suppose if you take the jasmine flowers, in the jasmine flowers, the yield of this essential oil only 0.04%. But in the case of concrete, it is 0.73, and in case of liquid CO2, it is 0.4%. So nearly the 10% yield is obtained in carbon dioxide. Though concrete gives the higher yield, but in the last column, I give the waxy materials. In waxy materials, in this waxy materials, it essentially only 0.2, and in case of concrete, it is 41%, but in case of liquid CO2, it is 4%. And all other marker compounds like hexanyl acetate, linalool, benzyl acetate, methyl anthranilate, E-alpha farnesene, and hexanyl, all are in its better amount or higher amount in liquid CO2 extract. So no doubt the liquid CO2 extract is profitable in terms of yield, in terms of its fragrance profile, and it is also contain very less amount of waxy materials. Similarly, the another important flowers which is mostly marketed by India, and it is the Pandanus fascicularis, which is known as the Keuda flowers. In Keuda, so actually here also we compare the different extracts. In case of yield, the Keuda is given in hydrodistillation only 0.03% and concrete 1.4%, and in case of liquid CO2 it is 0.34%. But all the major bioactive compounds like 2-phenyl ethyl methyl ether, terpenoforol, or alpha terpenols is also present a reasonable good amount in case of liquid CO2 extract, and it is very less in case of concrete. And though in hydrodistillation it also contain good amount, but its yield is less, very less. So in case of waxy materials, here in case of Keuda it is very negligible, less than 0.1%, but in case of concrete it is 61.7%, and in case of liquid CO2 it is 18%. So we can also push this liquid CO2 process for processing of floral fragrance, because it is a very delicious fragrance, and it is also very huge market nowadays. And in this final slide, so we get conclusion that if there is a floral process, we can go to liquid CO2. So I just keep adding one or two lines. In liquid CO2, we are not thinking about the supercritical CO2. Supercritical CO2 require very high temperature and pressures. So in case of liquid CO2, it is operating at a 10 degrees centigrade, and also its pressure is less than 70 bar. So this condition is easily achievable, and it is easily also scalable. So in case of industrial process, we can also think about the liquid CO2 extraction process. And suppose in case of Keuda, so I just give the example of Keuda. So in Keuda industry process 50 million flowers through hydrodistillations, because it is the present marketing of the Keuda flowers is only hydrodistillations, and it may be their farm authors. So by adjustment over some observant like this PG 400 or PG 600, but most important commercial form of this Keuda is essential oil. So India produces essential oil of value 6 million USD, and this oil is a very high value oil, and per kg of this oil is the fetch price 4,50,000. So when in the process of distillations, this distillation condensates, means this distillation water also contains 50 to 20% of this important oxygenated compounds. Because in case of Keuda, so the compound I discussed, this 2-phenyl ethyl methyl ether, terpenoforol, and alpha terpene, all are the oxygenated terpene compounds, and these are in some portions they are soluble in water. So due to this oxygen, So it is also some portions, so nearly more than 1000 ppm is soluble in water. So due to this solubilization, so nearly 15 to 20% of this oil is lost. These compounds are recovered. So now we just studied how to recover these compounds. So by this using this adsorption process, so by this adsorption process, we can recover this important terpene class of compounds by simple adsorptions. And then when you put in it, put a little amount of ethanol, then it will also dissolve into resins. And this process can be, or this resin can repeat or can reuse for number of times. So just I give a comparison how it is working. Suppose in case of distillation condensers, what the Keuda industry practice, they first extract the essential oil, and whatever the remaining water, they take this water and they, again only water they redistill. So in this process of redistills, so it is the first stage of waters. In this redistills, they able to isolate few percent of the essential oil. But still, the second phase contain 1.1% of oil. Suppose in 1 liter, this is 1.1 gram still in the waters. And finally, again they redistill the second water also. So finally, this 0.9% of or 0.09% of this essentially lost. Means in 1 liter of water, it is lost the 0.9 gram. So actually for processing of a 500 kg bag, they use nearly 5,000 to so for the, suppose in their commercial scales, so for a batch they use 5 to 600 liter of water. So due to this huge water they are using, so this loss is also quite high. So in the quality wise, this essential oil contain these two phenyl ethyl methyl ether, two phenyl ethyl alcohols, terpenforol and alpha tocopherol. This is only 0.3% of two phenyl ethyl alcohols. And similarly, this phenyl ether is 68%, terpenol is 69.2%, and alpha tocopherol 2.9%. So, but in the first stage, the waters, when you absorb these waters and they recover it, it contains high amount of phenyl ethyl ethers and high amount of also phenyl ethyl alcohols and terpenforol and alpha tocopherol. Similarly, in second stage, so this amount is phenyl ethyl little less, but we are isolated high amount of phenyl ethyl alcohols and the terpenforol, and these two are also very important oxygenated compounds. And similarly, in last stage, which is discarded by this industry, it also contains huge amount of phenyl ethyl alcohols and the terpenforol 20% and nearly 9.6% of alpha terpenol. So in combination of this oxygenated terpenoids, it is also contain the better quality as compared to the original oil, but still we are discarding it. So if we make this resin process in a big scale, in a commercial scale, then we can trap all the important terpene class of compounds, and then we recover it, and then also we can blend with this original oil and sell, so that we can get the better quality of this oil as a whole. So the resin we are using is known as the Amberlite X84 and the Indian 1014 MM2. So in which it is having the good absorption capacity, it can absorb 3.2 to 3.6 millimolar these compounds in 1 gram of resin. So its absorption capacity is very high. And if we fix this color once, it can also repeatedly reuse for a number of times. So next is this enzyme assisted technology. So how for isolation of terpenoids. So suppose we will deal with the class like wood biomass. Suppose in case of cedarwood oil, its value is 4,000 per kg, and sandalwood oil, its value is 25,000 per kg, and agarwood oil, its value is more than 50,000. It may be 60 or 70,000 per kg. It is a very expensive oil, which is known as agarwood essential oil. Similarly, the vetiver, so which my institute also promote a lot of vetivers, and this root oil also nearly 18,000 per kg. So actually for this all the woody biomass, so actually it requires 5 to 6 days for distillations. So because due to its woody nature, it needs more time. So farmers have burn this wood for distillations nearly 4 to 5 days. They just burn from morning and they light up in evening, and again the process is in the next day. So similarly, they continue a 1 day for 5 days. Suppose we are trying to intervene, so how to reduce the times? So by this we just use the enzyme treatment. So it will only enzyme treatment for 15 to 30 minutes. So it will reduce the distillation time to 6 or 8 hours. So definitely this enzyme. So actually what happens? This wood contains cellulose, hemicellular lignin. So actually, this wood, these hierarchical structures or this very complicated structure, the cellulose, hemicellulose, lignin, they did not allow the oil to leak out. So that it takes more time. Suppose if you treat with enzymes, so enzyme is slightly distorted the cellulose and hemicellulose and lignin these structures, and due to this, so if the oil is easily leaked out from this oil gland. So the yield of this essential oil, we found that it is also increased by 30 to 50%. So finally, this is reduction of time, and here is the, also reduction of the increase of the yield. And we are using the enzyme in, cellulose and hemicellulose 2:1 ratio. So we assume that this biomass contain more amount of cellulose and the hemicellulose less. So accordingly we decide, and by experimentally we validate that this is the right combinations. And similarly, for enzyme concentration, we are using 1 gram per liter concentrations. The essential oil or liquid CO2, if you select this final extraction by using hydrodistillation process or a liquid CO2 process, it also give higher yield, as well as the quality of the oil is also superior. So, for example, of this header road, suppose in a normal laboratory process, we found that for hydrodistillation, this threshold in hydrodistillation, it takes 12 hours, and in enzyme treaters, it takes only 6 hours. And here the nearly 50 times, 50% increase of this yield also, from 3.6 to 5.4. And similarly, in liquid CO2, it is suppose in fresh wood it takes 12 hours, the yield is 6.2, but in enzyme treatment only 6 hours, it is 8.1%. So similarly, here the reduction of time and also improve the oil yield also, and this oil yield is around 20 to 50%. And here all the important class of compounds, suppose in case of cedarwood, it contains the compound like hematolin class of compounds and also atlanton type of compounds. So here in quality wise, it is also contain higher amount of this hematolin and atlanton in essential oils. And for example, if E alpha atlanton with the major compound, so in case of fish, it contains 18%, and in case of enzyme treatment, it contains 25.8%. And similarly, liquid CO2 also gives a higher amount of this atlanton in the extract. So no doubt, liquid CO2 is little bit expensive, but it is a very useful and a very helpful process. And similarly, by enzyme treatment of this particular wood biomass, because its industrial value is very high. So if you pick enzyme for 15 to 30 minutes, we can enhance the yield of the oil. Then I am coming straight forward to our major crops, because this mentha abensis. So India is the #1 throughout the world, and particularly my institute also working a number of varieties. We have developed a number of varieties for this mentha, and promoted throughout this North India. So actually, this mentha, the major product is this mentha oils, and the derivatives are used in food, pharmaceutical, and perfumery. And the menthol is isolated from mentha oils through refrigerations, distillations, and centrifugations, and followed by drying. So actually, what the mentha industry is doing, so they first extract the oils by hydrolysis distillation process, and after extraction of the oils, they go for heat these oils to keep this oil at a low temperature around -40 degrees centigrade. So at this temperature, this menthol, which is a oxygenated monoterpenes, is crystallized, and it is settled down as a crystal form, and the industry slowly separate the upper part of the oil from the crystals. So actually, in mentha industry, they are selling one product as a menthol in the form of menthol crystals, and then the other supernath, which contain the other compounds, which is known as the spent essential oils. It is also selling out as the mentha oils. So actually, it is selling in the name of mentha piperita oils, which is known as the demethylized oils. So actually, here one of the example in the industrial process. So in this industrial process, what happened? This suppose it is mentha piperita. This is peppermint oil. So this peppermint oil is majorly cultivated in USA. So USA is the leading producers, and it is mainly used for the flower applications. So actually here the menthol content is less. But in our mentha, which is known as the mentha arbensis, so which contains 76% of menthols. And because of this variety improvement program of our CMAR, so we have developed number of varieties which contain high amount of menthols. So due to this high amount of menthol, so it is the most preferred essential oil for separation of menthol crystal. So only by putting the oil at a low temperature, they crystallize out the menthol crystals. but in this crystallization process, they initially got the 90% menthols. This is the composition of 90%, because in mentha industry sell this product in different grade also. So it is the 90% pure crystals, and again they go for 97% crystals, and again they found the gold crystals. So there is a different grade of this mentha processing. So here what happened? So when they separate out these menthols, so slowly this compound is improving, because initially the oil is, it is less than 1%, and suppose when we form the demethylage, it is the menthol crystal is separated out, and then this is known as DMO, which is known as demethylized oil. So in case of DMO, 20% means it contains nearly 20% of these menthols. So in this menthol, this polygon is increased nearly 3%, and in case of 40% menthol, it is around 2.5%. And what happened? Our industry selling this mentha oil as a menthol crystal, and as well as in the DMO. This DMO composition is very close to this peppermint oil. So actually, this DMO is replace the requirement of this peppermint oil, because there is a huge requirement of this peppermint oil. So due to it is not available as per the requirement. So actually, Indian industry push this DMO, and it can fill the gap of this peppermint oil. And due to this high amount of this polygon, so it is one of the toxic compounds. So when this percentage increased, so it is not accepted by the industry. So then the industry need any process how to reduce this polygon content. So so actually this is the next slide. I'll discuss the polygon a little late. So actually, what is the export mint oil and derivatives? So you will see this is a mint oil. So this 2010-11 it is produced 1292. So 1,292 tons of this oil, and this is the value in crore. This is 32.2 crores. And similarly, in 2013-14, it is produced 1,421 tons of this mentha oil, and its value is nearly 50 crore. And similarly, this value is in a present scenario, its value is also nearly 50,000 tons. And in this mentha oil, it separated the menthol crystals, and this is the export figures. And the second one is the demethylage oil. So it is in demethylage oil also, it is selling in the name of peppermint oils. So this is the mentha industry figures. Then I discussed about what is the polygon. So my main point is how to review this polygon. So here actually what about polygon? So polygon is a monoterpene ketone present in the leaves and the flowering tops of several members of the mint family. So actually in USA, so the major mint producer state is Idaho. So in Idaho, so it is cultivated a huge amount of this mentha piperita. So actually in 2014, this polygon content is increased 2%. So when it increased 2%, then this farmer find challenge for its marketing because of this toxic nature, and it is not further regulatory issues. So then, as per the toxic report, polygon was added to Prop 65 by Office of Environment Health Hazard Assessment to the list of chemicals known to cause cancer. So it is a cancer-causing agent, and the polygon has very limited application in fragrance formulations and the healthcare products. And the polygon is fully prohibited by US FDA in food and cosmetic application. Now it is totally prohibited. So due to this challenge, our mentha industry who is selling the GM also facing the same challenge. Then industry approach of what is the solution. Then for this industrial problem, we take up this challenge, and as per this rich guideline of Europe, it is fixed that the DMO should contain less than 1.5% of polygon. Similarly, the Indian DMO contains up to 3% of polygon. Thus, require a green and economic process how to convert this polygon to some other compounds, so that we are overcoming these regulatory guidelines. So as per this industry request, so they suggest that I would suggest staying far away from high polygon oils and focusing on low to zero polygon. That means they require the DMO which contain either no polygon or very little percent of polygon, so that they can fight the regulatory issues. To overcome this, we just make a silica-based catalyst. So and at very low temperature and very low hydrogen pressures, we convert most of the polygon into menthone and isomenthane. Because in case of this mentha oil, it already contains menthone and isomenthane. So if we'll go to the previous slide. So in case of this mentha oil, so it already contain 8.3% of polygon and 6.1% polygon, and our pipette also contain a little more amount of this menthone and isomenthane. Though our DMO also contain menthone and isomenthane, so it will selectively convert this polygon to menthone and isomenthane. So its percentage is suppose 1 or 2% will increase, but it is not has any regulatory guidelines, and it can be passed. So according to this, we make this polygon to convert to this menthone and isomenthane in a very simple process. And here the above conversion is at very mild conditions, and the conversion is also equally effective if we take the pure compound or we take the absorb the DMO or polygon rich compound also. So by this process, we help the Indian mentha industry to selling this DMO. And similarly, in another form, this polygon can be also converted to thymol. Suppose in our CMAP, we have the number of variety, and one of the variety also contain, which is known as the same disease, which contain nearly 80% of polygon. So actually, what is the need of this variety? So if this is very high toxic, it has no meanings. So to sort out this issue, we also make this polygon to thymol. So this thymol is one of the important compound which is available in argan oil, and they also there is a thyme variety also, thyme vulgaris. So it is also contain thymol. But we also make a chemical process by using a novel catalyst. So to make this polygon to thymol. So it is a suppose cyclohexane, and we make this in aromatic. So here major thing is it is having the no chiral centers. So it is having no issue of the enantiomer specific. So by this. So suppose if this polygon value is 1,000 rupees, now thymol value is more than 2,000 rupees. So by using this catalyst, so we also make polygon to thymol, and this conversion will also attain very low conditions like 70 centigrade and 15 minutes time and a 30 psi pressures. So this conversion is also equal effect if you take the after the seal, which is very essential oil also. So this is one of the catalyst process. And similarly, this polygon to menthofuran, because in case of mentha pipirita, it is contain one of the compound with mentha furan, which is absent in our mentha arbensis oil. Suppose if you go to this slide. So here this mentha pipirita oil is contain mentha furan, but in all our mentha oil, it is absent. So we also make a process how to suppose make this polygon to mentha furan. It is also possible. So by using a composite catalyst, we make this polygon to methylphenol. That is, you are asking something? Hello?
Yeah.
You are asking something?
No, you go ahead. You're fine.
Yeah. Okay, fine. So after mentha, the second important essential oil is the lemongrass, because after mentha, the leading crop the farmer is practice is in lemongrass, and it is known as the Cymbopogon flexuosis. And this major compound is citral, which contain two compounds like geraniol and mineral. So it grows about 30,000 hectare of area, mainly the southern part of the state like Kerala, Karnataka, UP, Chhattisgarh. And this lemongrass is used in traditional medicine for pain relief, for stomach problems and fevers. It has antioxidant, anti-inflammatory, and antifungal properties. And similarly, how to make the value, because once a time this lemongrass is fetched nearly 15 to 1600 per kg, but now it is coming to 1000 to 1100. So due to this large production, this price is also little decline. So to make this agro practice sustainable, so make some chemical interventions, make some value additions, so that farmer getting the minimum price or a better price or practice this crop year after year. So for this, we just make some value addition work. So here this citral. So citral is by a catalytic process, is a nickel catalyst, we can make to citronella. Citronella, in comparison to lemongrass oil, citronella oil having the better price and it has the better demand also. So by making a simple process, we make this lemongrass oil to equivalent to the citronella oils. And again, by the citronella, by using composite catalyst, we make the paramethylene 3 diol. So actually here in this chromatom, so the citral is totally converted to this paramethylene 3 diol, and it is the two chiral bonds. One is plus PMD and one is minus PMD. So actually, when you test this against the mosquito, it is already reported it is a very highly and effective mosquito repellent, and it is replace all the synthetic chemicals like DET. So now industry use the DET, which is a nitrogen based compound, which is very toxic. But still, we are regularly using all our mosquito repellent products. So to make this thing into the natural identical and naturals, so this paramethylene diol is a very effective natural mosquito repellent, and which is only used by Johnson and Johnson till date. So by using a catalytic process, which is very selective and effective for PMD synthesis, and we attend nearly 96% of conversion. And these two enantiomers, which is one is the plus PMD and a minus PMD. So plus PMD is little higher, 1.5 ratio, and then this minus is 1 like this. So by this ratio, and both plus PMD and minus PMD is very effective against the mosquito. So it may be its mosquito repellent property and a larvacidal property. So both are showing very prominent activity. So in case of larvacidal activity, if you put in water and some water sources, it is also not allowed to grow the mosquitoes. So it's showing very prominent activity as a repellent and as an larvacidal. And similarly, citral to nerole and geraniol. So in this nerole and geraniol, it is mainly obtained from the rose flowers. So by using simply oxidations, we make the citral to nerole and geraniol. And here the nerole and geraniol, still we are only obtained 30% of conversions. So if we can manage this catalyst in a more effective manner, so then we can make this citronella oil to a rose fillings. So to make this citral to geraniol and nerole. And then another important reaction is so citral to menthol. So how we can make this menthol also from a natural source, because citronella or lemongrass, it is also produced by the plant, and menthol is also produced by the plant, and both have been coming in the monoterpene class. So by using a process, we first make citral to citronellal, and then again another catalyst we make citronellal to isopolyol, and then isopolyol to menthol. So here it is a three-step reaction. So in first step we are using nickel activity circle, and in second step we using aluminum boron impregnated sodium gamma zeolite, and in third step the catalyst is 1% palladium and or ruthenium in activity circles. So for this reaction also, so this above conversion is also attempted at very mild conditions. The catalysts have been displayed better catalytic activity, and these catalysts are recovered and reused in multiple batches. So this is the beauty of these things. So then I little more elaborately discuss how to make menthol from citral. So actually, then first we see what is the global demand. So as per this global demand, from year after year, it is slowly increasing. So the menthol demand is increasing in global, and India is the number one in menthol productions or mentha oil productions. So, but still, as per the 2018 figures, we are only 60% meet out from this natural source. Still, 40% is coming from the synthetic source. And similarly, though India is a major producer, India is also major consumer also. So in the consumer consumption figures, India nearly 32%, China 21%, and Europe 20%, USA 19%, and other 8%. So no doubt this India, China, and Europe and USA, these countries are major consumers of this mentha or menthol products. So, but still, by developing number of varieties or by promoting cultivation, still we are not meet out the global demand. So for these things, we just discuss how to prepare this catalyst, how to characterize this catalyst, and how to semi-synthesize this menthol from lemongrass oil. Because lemongrass is also produced very high amount, and lemongrass is a low value essential oil. So if we make this lemongrass oil and we use the citral of this lemongrass oil to menthol, then it is a very value addition work, and our farmer will get the better price. So by this, suppose here the first step, this is nickel and activity circle, and around 60° and 40 minutes reaction time, we get 95% of conversion from citral to citronella. Then in the second catalyst, by using aluminum boron zeolite or tin boron zeolite, So the conversion rate is more than 95%. And the third reduction step, it is 1% palladium and 1% ruthenium. This conversion is more than 97%. So the major feature of this reaction is the above conversion is attained at very mild reaction conditions. The catalysts have been prepared and displaying the better catalytic activities. These reactions, and particularly this conversion of citronellal to isopolyol, it is the key reaction step, and it is the rate determining step of this three-step reactions. So then we'll more focus on discuss how to make this acyclic compound, which is the citronellal, which is not a cyclic form. So main here the citronellal is cyclized to this isopolyol, and this is the main reaction step. And this reaction, when we saw the literature, it is coming under these Prince reactions. So what is the Prince reactions? Then there is a electrophilic additions of an aldehyde or ketone to an alkene and alkyne. Here this is an alkyne and here is the aldehyde. So due to this alkene and aldehyde, and it is in the same molecules, it just make a cyclic bonds. So by using this Prince reaction, we first make this citronellal to cyclize to isopolyol. So here we prepare this catalyst by using the zeolite base, and then we first prepare by taking aluminum nitrate and tin chloride to this aluminum implicated zeolite, and then we integrate the boric acid, and by using boric acid we find the final catalyst is the aluminum sodium gamma zeolite boron and a tin gamma zeolite sodium gamma zeolite boron and a aluminum gamma zeolite boron and tin gamma zeolite boron. We prepare this four different catalysts by using the zeolite base, and this catalyst ratio we have decided by taking suppose 1% of boric acid, 1% of this tin salt, and 4% of the zeolite to different ratio. Suppose from this ratio to 1% of boric acid, 2% of tin salt, and 7% of zeolite. By using the different combinations, we found that the most active composition is 1% of boric acid, 1.8% of tin salt, and 6% zeolite. It gives the very prominent conversions of citronellal to isopolyol. Similarly, in case of second category of catalyst, we are taking 1% of boric acid and 1% of aluminum salt and 4% of zeolite to 1% of boric acid, 2% of aluminum salt, and 7% of this zeolite. And here also by 1%, 1.6%, and 5.5%, we are getting obtain the highest amount of conversions. So finally, we decided the two catalysts for the final reaction. So here, when we take this reaction by using this aluminum sodium gamma zeolite boron and a tin sodium gamma zeolite boron, we found that this initially the substrate is citronellal, which is decreased up to almost to negligible, means 0, and slowly this isopolyol is increased. And this isopolyol having the 8 chiral centers, because if we see this molecule, in this molecule, there is 3 chiral centers. This is the chiral centers, this is the chiral centers, and this is the chiral centers. So there is a 9 isomers are possible. But in case of plant, suppose plant is only produce minus isopolyol and minus methyl. Suppose in the biosynthetic pathway in which the plant produce, it is only produce the single image. But when you try to make this thing in chemical route, it can produce the 8 images. So from these 8 images, we found that this minus isopolyol is highest, and also it also produces a little amount of new isopolyol, new isopolyol, and isopolyol. So these are also produced somewhat amount. And in this catalytic activity, there is a 96% of citronellal conversions having 100% selectivity by using aluminum, sodium zeolite, sodium gamma zeolite, and boron. And when you use the tin sodium gamma zeolite boron, this conversion percent 98% and the selectivity almost 100%. And by characterizing this catalyst, we found that this tin catalyst having better UV absorbance, and in comparison to aluminum catalyst. So here the tin oxide is coming around 219, so it gives a very prominent peak. In case of iron also, we found that this is the tin oxide, aluminum oxide, and boron oxide, all three are present. And so our catalyst is well integrated all the important metals. And in XRD analysis, we found this tin and aluminum sodium gamma zeolite catalyst is having a better crystallinity. So both tin sodium gamma zeolite boron and aluminum sodium gamma zeolite boron having better crystallinity in comparison to only aluminum gamma gelate boron and a tin gamma gelate boron. And when also we try to replace the base material, instead of gamma gelate, we are taking the beta gelate, so its crystality very less. And particularly this gamma gelate is giving better reactions because the gamma gelate having the pore dia is higher than the beta gelates. So this pore diameter also play an important role for this conversion. So this thing is confirmed to this surface area and pore dimension study of the catalyst. So in case of suppose base material, we are taking sodium gamma gelate and a hydrogen gamma gelate. Here the surface area is very high and having reasonable amount of pore volume and a pore dia. But when we integrated tin and aluminum in this base material, so here the tin, sodium gamma gelate and aluminum gamma gelate, it is slightly decrease of the surface area and slightly also decrease the pore volumes, and but here the pore dia is increased. But when we integrated in this hydrogen gamma gelate, this is the surface area is a little higher, and this pore volume also little higher. But and this is also little higher. But when we integrate in the boron again, so here the reduction of surface area and this pore volume is almost there is no significant changes. And in case of this pore volume, pore dia, it is slightly increased. But in particular, our interest catalyst like sodium, tin, sodium gamma gelate, boron, and aluminum, sodium gamma gelate, boron, here the surface area is drastically decreased. And also the total pore volume also decreased. But the pore diameter is significantly increased. From 1072, it is increased to 246.7 and 291.9. So here the pore radius is increased. So this pore radius is playing an important role for this selectivity and for this conversion. So finally, this catalyst we are using for further characterizations. And here we found in EDX and ICP OES analysis, this is the composition of our final catalyst. And in case of this high resolution image, like same, this aluminum catalyst, base catalyst is highly homogeneous. It is totally homogeneously distributed. But in case of tin, it just makes some little layers, and this thing is confirmed to TEM analysis. In TEM, this tin, sodium gamma gelate, boron, it forms the layer type of structures. But in case of aluminum, sodium gamma gelate, boron, it's just a homogeneously mixed. And then the important factor of this catalyst is the acidity. Suppose the catalytic property also depends upon the acidic side and the basic side of the catalyst. So initially we determine the stability of this catalyst by using TGA, and it is very highly thermostable. So there is a very little elevation initially due to this maybe this moisture content. And when this catalyst we integrated in pyridine, so we found two different peaks. So one around 150 to 200. So this is a very low acidity side, and another around 550. So it is due to the this is the strong acidic sites. So there is a two different acidic sites, and this thing is again confirmed to nitrogen repeat experiment. From this experiment, we found that our important catalysts like tin, sodium gamma gelate. So this bottom, this is the peak, and similarly this aluminum, sodium gamma gelate, boron, and this is the peak. And in these two catalysts, it contains the higher amount of Lewis acidity because this lower range it is due to the Lewis acidity property of the catalyst, and this higher side it is due to this Bronsted acidity. So actually these two catalysts, this sodium gamma gelate based catalyst having the better acidity side in comparison to this tin gamma gelate boron and aluminum gamma gelate boron. Here it having little bit Lewis acidity, but it is very negligible Bronsted acidity. And so why this acidity arise? So again we confirm this through its oxidation states. So in this oxidation state, this is the aluminum based catalyst, and here this XPS analysis is for aluminum. Here it is a tin based catalyst, and here the aluminum content is less, so it gives a very lower abundance here the aluminum. And in case of tin, this is also a little less abundant in comparison to aluminum based catalyst. And similarly, when you measure the tin and tin oxidation sites, so here it is coming around 487 and 497. So here uh, these two catalysts like tin, sodium gamma halide boron, and tin, hydrogen gamma halide boron. Here, this sodium gamma halide giving the higher oxidation state yeah, in X-phase analysis, and this hydrogen gamma halide give the less oxidation state. So this is due to the 3d by d5 by 2, and this is the 3d t by 2. So actually this is due to the tin plus 2, and this is the tin plus 4. So these are the two different oxidation state is confirmed through XPS analysis. Then what happened? Suppose this oxidation state is again confirmed through the suppose in different structures. Suppose when we found the literatures, so we found that this in case of this boron, it exists in tetrahedral boron structure and a trigonal geometry also. So this sodium chloride is from the sodium borate forms. So this due to this it becomes the tetrahedral boron forms. But this catalyst having no sodiums, so it is in the trigonal forms. So in this tetrahedral forms, this is contribute to the more concentrated acidity size. But we conclude that it is the mixture of this tetrahedral form and the trigonal forms. In case of sodium-based catalyst, it contains more amount of these tetrahedral forms and very less amount of these trigonal forms. So due to these different forms of boron coordinations, so this is silica or silicon dioxide, which help to generate different level of oxidation states and which signify is acidic properties. So finally, this particular catalyst having the high acidity size means both Lewis acidity site and mustard acidity sites, as well as having the better 4-dia which facilitate for this specific or specific reactions. So here we again come to this chiral form. So how this catalyst is working? Suppose in case of we take the
Hello, Dr. Rao. Hello, Dr. Rao.
Yeah.
Someone has, I mean, by mistake shared their screen. So you please again reshare your screen, because now the your presentation. Yeah. Someone has by mistake done that. Please.
Okay, now screen is not moving.
Yeah. Actually, your presentation is not visible. So you please, present. Yeah, you click present now again.
Okay. Please give me a minute. Okay. Thank you.
Yeah. Okay, I have done from my part. Is it visible to all?
Yeah. Dr. Megal.
Hello, yes.
Yeah,
Megal, it is visible.
it is
Okay.
visible.
Okay. Now, thank you.
Yes.
Yeah.
Oh,
Okay,
yeah,
continue.
thank you.
Yeah.
Yeah, thank you, Dr. Meghal, for solve this issue. Yeah, so suppose then I discuss about the chiral enhancer specific synthesis. So here, if you take the plus citronella as substrate, so here no doubt we are obtaining the minus isopolygal in the major isomers, but still we are obtaining plus neo isopolygal, plus neo isopolygal, and plus isopolygal. So actually, what happened? So this plus citronella is giving the 4 different chiral images, and for this menthol synthesis only minus isopolygal is important. Suppose plant only synthesize only isopolygal, and it again by synthetic pathway it only produce the minus menthol. So very specifically plant synthesize the minus menthol. So here, suppose if you go to this chiral analysis, we found that when we take the plus citronella as a substrate, so we obtain only minus isopolygal and other things are plus. Means plus neo isopolygal, plus neo isopolygal, and plus isopolygal. And similarly, if minus citronella as a substrate, then here the isopolygal is in plus forms. This is plus isopolygal, and the minus neo isopolygal, minus isopolygal, and minus neo and isopolygal. So actually, so how to make this reaction in the specific is also one of the important aspects in chemical synthesis. So for that, suppose I'll discuss this chiral also later also. So again, by using different reduction catalysts, we have prepared different reduction catalysts, and we found that only 1% ruthenium in activity circle or 2% palladium in activity circle or 2% palladium in activity circle, it gives the best reduction properties for conversion of isopolyol to menthol. So here, by using the catalytic conditions, so when the pressure is 40 and the temperature is 60, we obtain 97% of conversions. And in the case of 1% ruthenium in activity circles, we obtain 89% of conversions. So actually, these two catalysts, the bottom one and this reaction conditions, we are again optimized how to obtain the higher amount of this reduction products. So here also, by using this catalyst, we found that this 1% palladium in activity circle, it having the 90% of conversion, having 100% selectivity. And in case of ruthenium in activity circle, it gives 88% conversion, having 100% selectivity. So here, initially this isopolyol is almost negligible after an hour. And similarly, this minus menthol and like neo menthol, isomenthol, and neo isomenthol, it will also produce some little amounts. So here, when you take the direct oil, so in case of citronella oil, so it contains both plus citronellal and minus citronellal. So, and in this case, when you go through these two-step reactions, so finally we will obtain this plus menthol and minus menthol in the similar ratio. And when you take only plus citronellal as a pure compound, we found it is selective for with the minus menthol. And in case of recipe mixture, if we take plus and minus citronellal, then it is also produced in the similar ratio. And in case of minus citronellal, it gives the plus menthol. And suppose in case of standard, this is minus menthol, this is supposed to peak. When we analyze through this chiral GC analysis, we found that it is also give the chiral mixtures. But if you are taking the pure substrate, as a plus citronellal as the pure substrate, then only predominantly we found that it is produced the minus menthol. So this is the chiral things. Suppose if there is a plus citronellal and a minus citronellal, so we can get all 8 isomers, but this isomer is more than 94%. So this minus isopolyol is very higher in our catalyst. And again, by reductions, we are also the same isopolyol reduced to minus menthol, and other things are reduced to some different images of the menthols, because in the cyclation step, the stereo form is already decided. So suppose here in the cyclist form, these all stereoisomers are obtained, and by reductions, the corresponding isopolyol is converted to its corresponding menthols. So though we are obtained nearly 95% of isopolyol here, then also in menthol case we are obtained nearly 94% of menthol. Suppose the main important aspect is, so how will make this reaction in the essential oil? Suppose we are choosing eucalyptus oil. Suppose why choosing eucalyptus oil? Because it contains higher amount of citronella, and also this eucalyptus contain select will the plus citronella. So in this case, it is only composed of 98% of plus citronella. So here, when you make the two-step reactions, so this is the original essential oil which contains citronella, and by first step and by after chemical modifications, we found that this citronella is totally converted to menthol, and by using the same menthol industry process by taking around minus 40 degrees centigrade, so nearly 30% of menthol we screen out. Means by crystallization process, we obtain 30% menthol, and still this after menthol separation, the essential oil contains 17% of menthols, because when this menthol concentration is very less, so less than 20%, the remaining menthol is not crystallized out. So same in also our menthol oil also. So when this concentration is around 20, so it is very difficult to crystal the rest 20 amounts. Means it is the minimum threshold concentration. When this percent is more than 20%, then the remaining menthol is crystallized at minus 40 degrees centigrade. But when it is less than 20%, so due to the presence of other compounds in the essential oil, the remaining menthol in the solubilized form. So by using a simple process, we also crystallize out menthols. So this menthol isolation by low temperature freezing process. So in the similar line, which is practiced by our menthol industry. So it is a very good technique the industry can be adopted, or our lemongrass, or our citronella, or our eucalyptus can be also evaluated.
Dr. Prasad.
Yeah.
Sorry to interrupt. I think some of the participants are still having problem that your screen is not visible. So can you please
Okay.
read? Some of them are not
Okay.
able to pull your presentation.
Okay. 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 I'll reload it. Okay. Please give me a minute. Yeah. Okay.
Okay.
क्या करना है वीडियो चालू है सामने आएगा Yeah, now visible. Hello. Yeah, Dr. Dirida, now visible.
No, no.
Yes, it is visible.
Yeah, for me it is visible.
Okay,
Yeah, yeah.
for some of the participants, including me, it is not visible.
It is visible from my side.
Yes.
Now it is visible, or I reload again.
You
No,
restart. I
it
hope
is
you restart.
visible.
Sorry.
You
It is
can
visible.
restart
It
it.
is visible.
Yeah, yeah.
Madam,
Okay,
The
Dr.
question,
Dale.
you can go ahead. It is
Okay, okay,
visible.
okay.
Yeah.
Okay, okay, thank you. Thank you. So, yeah, okay, sorry for interruption. So, for this catalyst reusability, the major advantage is this catalyst is heterogeneous in nature, and it is robust and reusable. The rate of products in the first and the second step using tin, sodium, gamma zeolite boron, and 1% palladium activated charcoal is stable up to 3 to 4 subsequent runs. So only 10% loss we recorded in 4 successive rounds. In this particular summary, the developed catalyst was selective and efficient for conversion of citral and citronellal. In the present catalytic reduction process, we obtained 92 to 95% of minus menthol, and it confirmed that citronellal was the ideal substrate for the production of minus menthol. So for this, the essential oil which is very highly abundantly available in India, which is one is the lemongrass, second one is the citronella and eucalyptus. So it can be value added to menthols. So by only promoting mentha cultivation, we are not meet out the demand of the globe. So maybe the synthetic menthol is the alternate choice. And I added things. Yeah. So actually, particularly by so we are mainly focused on this essential oil because this essential oil is also synthesized by plants, and when we are taking biomass index, so the main goal to distinguish the synthetic menthol from the natural menthols. So people are doing the biomass index test. So in our biomass index test by using this essential oil, so it is also 100% bio-based. These essential oils can be used for a value addition to minus menthols, and after little purifications, we also substitute these natural menthols with these semi-synthetic menthols we obtain from the other essential oils. And similarly, these essential oils like minus menthol, it is a very well known used in food, pharmaceutical, and some cosmetic applications. Similarly, menthols, linalool, and carbon, similar to other these essential oils obtained from the other mentha varieties, all are now used in food and flavor industries. And similarly, the importance of terpene esters, because some of the plant is produce very high amount of alcohols, means the oxygenated alcohols. So actually, what happens suppose when this essential oil which contain higher amount of alcohols, when it used in any formulations, it can be dehydrated. So it will lose its original properties. And similarly, this terpene ester having the higher fragrance profile in comparison to its corresponding alcohol, means its corresponding terpene alcohols. So similarly, people are using organic acid, halides, and anhydrides for ester formations. And terpene esters have a characteristic long-lasting floral woodic aroma and used in perfumes and cosmetic products. The manipulation of terpene alcohols and its corresponding esters can give the alternative fragrance with better olfactometry quality. This esterification is carried out in acetic acid, which act as adaptant and solvent. So this type of reaction is coming under green chemistry, and now it is categorized as solvent-free synthesis, because in this esterification process we are not using any halides or anhydrides, only using acetic acid. So already acetic acid used in the foods in the form of vinegars, and now in green chemistry definitions, so it is also coming as a solvent-free synthesis, because this acetic acid is used as a adduct as well as a solvent. So by using this principle, we are mainly taking this pinene to bonyl acetate, because this you may be aware about this Bacillia serrata. So this Bacillia serrata, it is this resin which contains the active molecules which is known as the bosulic acid, which is used for the cancer applications. So, but this Bacillia resin also contains good amount of essential oil, and it is mainly collected from forests like Jharkhand, Chhattisgarh, Odisha, and Andhra Pradesh forest. So now this market is nearly 3,000 crore in India. So, but our essential oil is very inferior quality, and now the major producer of this essential oil is Somalia. So now this the essential oil from Somalia origin brings the better value and a better quality. So but our oil is they treat as a little inferior. But in Somalia oils, so this essential oil contain the bonyl acetate and terpene acetate. So then, what our case we are getting mostly the hydrocarbons like alpha pinene, beta pinene, and alpha fusin like this. So it is nearly 70% in our essential oil. So then we just as per the some industrial meat, we take this problem, and when we use this alpha pinene and substrate by using acetic acid and some zeolite based composite you are using, so it's very selectively converted to bonyl acetate and terpene acetate. So suppose in case of alpha pinene, it is very less amount in this essential oil, and it is converted to bonyl acetate and terpene acetate. So this is one of the work which you try to help industry. So how to make this Bacillia oil, which is in the high commercial demand, to somehow like the Somalia origin. And similarly, our one of the important aromatic crop, and it is huge cultivated in state like Maharashtra, Gujarat also. So very huge cultivation of Amarja in Gujarat also promoted by CIMAP. So actually this essential oil contains 70% of geraniol. So by the 70% geraniol, once this Amarja oil pays nearly 3,000 rupees, and now its price is around 1,500. So it is a 50% reduction in price because of these huge plantations. So then we try to make this geraniol to geranyl acetate. So by using this lipase, this one of the commercial lipase LM10, so we make this geraniol to geranyl acetate. So actually this geranyl acetate is very high amount in geranium essential oil. So which is a very important essential oil, which mainly till that also India imported from France. So can we make this geraniol which is available from this Pamarja oil to geranyl acetate, so that we can make some substitutions of this geranium essential oil? This is the one of the activity. And similarly, in our this aromatic garden also, and our breeder also looking hard to make different type of oxymums. So we have the a number of oxymum varieties. So in a supra institutional project, we got a project on specific oxymum. So in this program, our breeder making number of varieties. So actually, our three core varieties like Sim, Sisir, and like other varieties also, it contains high amount of linalool. So particularly this linalool, so it can be also converted to linaloyl acetate. So though it is a terpene alcohol, it is little difficult for chemical transformation. So similarly, by using this enzyme and using acetic acid, so we also converted 50% of linalool to linalool acetate. And some of our important essential oil like bergamot oil, which contain linalool 30 to 59% and linalool acetate 15 to 37%. Similarly, lavender oil, which is mostly imported from France also, so which is also contain linalool 20% and the linalool acetate 47%. So if our oxymum varieties or oxymum line which contain higher amount of linalool, if you will convert some of the percentage of linalool to linalool acetate, so this blend it can be little bit replace the requirement of lavender and bergamot oils. So actually this is also one of the industrial related activities. So finally, the aromatic biomass. So actually, after isolation of essential oil or after getting this secondary metabolites, so what is the impact of this primary metabolites? So for that, so actually here the advantage is we have the huge amount of aromatic biomass, and this biomass is obtained after pre-treatment. Means all the biomass mainly in the field is going for hydrodistillation process. So in this process of hydrodistillation, it is already getting 3 to 4 hours of pre-treatment. So like your other agricultural residue like wheat and paddy, it has been no pre-treatment step. So after this pre-treatment, and though it is a grassy biomass, so it can be used for different applications, and it is the easier substrate to use for chemical conversion that we say. So for that, and if the when analyze this chemical compositions, this cellulose, hemicellulose, lignin, it is very close to the other agro residues. So therefore, our main concept is how to use the cellulose to different chemical productions via glucose. So first, it will depolymerize this cellulose to glucose, and this glucose can be used for production of HMF. So HMF is one of the very important intermediate for synthesis of number of aroma and food bearing fragrance. So here the concept is, so we are getting very huge amount of aromatic biomass, so nearly 70 lakh tons per year. And similarly, in particular mentha, we are often half of this biomass because total North India is the cultivated this mentha. So after the distillation, we are getting cellulose, so which is the rich source of CC sugars, and this hemicellulose, which is the composition of C5 and CC sugars, and this lignin, which contain the aroma chemicals like phenylpropenates. So here for that we develop a process. So we develop a chemical process by using imidazolium based solvent, which is not much acidic. Now paper and pulp and paper industry using this chloride and the alkali for delignifications. So to avoid this huge load of this alkali and this chlorochemicals, so we develop a little bit greener process for isolation of cellulose. So first by organic acid for imidazolium solvent, we get the lignin, and then this rest biomass by using imidazolium and very weak alkali. So then we get the hemicellulose, and this rest part is the cellulose. So in this process, we isolate cellulose and hemicellulose and lignin, and in a very pure forms, and nearly 85% we are recovered, because most of the things when this pre-treatment is going on, so mostly this hemicellulose and part of the lignin lost. But in our this mild process, we recover most of the biopolymers. And by this reaction process, so we can also synthesize this 5-hydroxymethyl furfural from cellulose. And this hydroxymethyl furfural having the number of applications. So here this hydroxymethyl furfural can be used in 4 flowering and fragrance chemicals like 2-furan methanol and 2,5-dimethyl furanol. Like this, all these furan derivative chemicals are very high demand in flower and fragrance industry. And similarly, it can be derived to chemical intermediates, can be derived to high octane fuel like 2,5-dimethyl furan and like some biopolymers. So for that we just develop a process. So how to use the cellulose to hydrosimple purpural? Though there is a number of things is reported. So like DMA and the lithium chloride is used as a solvent for the synthesis. And here the main thing is this dimethyl acetamide and lithium chloride. So once it is used as a solvent medium for these reactions, and after HMF synthesis, we cannot isolate the HMF. So this is the main thing because this lithium chloride and DMA is also soluble in almost all the solvents, so very difficult for its purification steps. And similarly, in case of iony liquid, so it is also giving good amount of conversions, like 50% conversions and better purity. But main thing is it is also very costly iony liquid. So the main processing cost is going for this iony liquid preparation or AC procurement. And this, but we prepare a very eutectic solvents like choline chloride and the citric acid. So by hitting this thing into it in one ratio, and we also found that the solvent system is easily prepared with hydrogen peripheral, and due to this UTT mixtures, it can also easily isolated through solvent partition methods. So for this, we developed the catalyst like zeolite hydropolyacid catalyst. So like beta zeolite phosphomolybdic acids, gamma zeolite phosphomolybdic acids, beta zeolite phosphotungstic acids, and the gamma zeolite phosphotungstic acids. So these are all coming under the zeolite and the polyhydropolyacid catalyst, and these are very ideal catalysts for this particular solvent system, and we are getting good percentage of this hydrogen preparations. And similarly, another scheme just recently we have started in collaboration with our microbial labs. So actually, they use this distillation waste biomass as a substrate for production of lipids. Suppose we have the number of oleaginous yeast in our microbial labs, and by using different stress conditions, because they use heavy metals, nanoparticles, and UV irradiations and iony liquids, and particularly and also salinity. So by using simply sodium chloride salinity, by increasing some amount of sodium chloride stress, this yeast produce good amount of lipids. It may be around 5% of this lipids from this biomass, and this lipids were isolated. And again, in characterizations, we found that it is also contain high amount of unsaturated fatty acids. Suppose people see this figure. So this is only oleic acid is around 20%, linoleic acid is around 22%, and linoleic acid is around 10%. So nearly it produces 55% of unsaturated fatty acids. So this fatty acid is a very good and ideal source for production of chemicals. So here, suppose in case of oleic acid, linoleic acid, and linoleic acid, we can easily convert it to ricinoleic acid, or by direct conversion also, it can produce the different lactones like plus gamma decalactone, plus gamma dodecalactones, and plus delta decalactones. And all these lactones are very highly used in flavor industry. And in case of this plus, because in original, this is the originated from either ghee or from fruits. So in ghee and fruits, it is only present in the plus form. So here this is all these decalactones having one chiral centers, and it can form either plus image or minus image. But in case of chemical synthesis, it forms both the images. But in biotransformations, it is very selective, and it gives the plus image. Suppose we try to synthesize these chemicals from the ricinoleic acid, and by using these step reactions, we finally obtain 70% of conversions. But still, it contains the plus minus decalactone. So in this case, we are not selectively synthesize only a single isomers and mainly the plus isomers, which is very important and naturally available for flavor applications, because these decalactones are the natural sources, ripe fruits. And similarly, same reaction we try from biotransformation process. Suppose here instead of this number of fatty acids, we select this castor as a substrate, and by simply we get the free fatty acids, and by enrichment we get the 80% of this. Initially, it is 80% of ricinoleic acid, and by purification process we find we enrich this distillate acid to 95%. And this 95% enrich as a substrate we use for biotransformations. So our microbial peoples isolated a very peculiar yeast. So which biotransform this distillate acid in 72 hours to only produce gamma decalactons. So here, in this biotransform process, we only obtain the plots image having 75% yield, and in case of here, we did not detect any minus image. And bio-based index test, so if it is natural or synthetic. So when we will test in bio-based index, so it is 100% matched with the bio-based. That means it is coming from the naturals. Though castor oil is already obtained from the natural source, and all its carbon is from this natural origin, so that it is obvious that our bio-based index is matching with the whatever the decalacton we obtain from the fruits. So actually in this bio-based index, they see what is how many percentage is natural carbon. So no doubt in this structure, all the carbons are natural. And in this analysis, we clearly indicate that suppose if it is bio-based, suppose in this case, it is only produced the gamma decalacton, and this is from the biotransformation process. It is also contain the cross gamma decalacton, which obtained from the this biotransformation process. But in chemical transformation process, we get the 50-50 mixtures because and it is a chiral mixtures. Suppose if this thing we transform to biotransformation process, so it is only can get the one image, and it is very close to the nature identical source. Suppose the merit of this biotransformation process is, suppose in chemical synthesis plus gamma decalacton was found to 65% bio-based and 35% carbon was petroleum origin in it. Suppose it will synthesize from petroleum source. And similarly, nowadays Simirise, Cadbury, and SES International are produce this compound by chemical synthesis route, and only one patent claim which claim that they are obtained 25% yield of gamma decalacton from distillate acid by fermentation process for 10 days. Means it is a very long fermentation times, and there are species that did not disclose also. But in our claim, we found that this gamma decalacton produced by this novel cell can label as natural flavor according to definition of CFR 21 section 101.22 and EU flavor regulations. So according to definitions, the chemical which produced through biotransformation process and the substrate is also from the natural sources. So the derived product is called as the nature origin or nature identical. So in this process, we are obtained 75% of this plus gamma decalacton. And now some of the company like Simirise and Cadbury already they launched their products also. So in this present process, as tentatively we calculated, so our processing cost and production cost is less, nearly 15 USD. So as per the market survey, we found that if it is chemically synthesized, its value is 180 USD, and if it is biotransformation process, then it is 300 USD, and if it is isolated from the fruits, so which is known as the very natural or a primitive origin, it is nearly 6,000 USD per kg. But this thing is very expensive, and it is also coming under the debate of 4 versus 12, and we are using huge amount of fruits because fruits contain only maximum 2 to 3% of the decalacton. And finally, in conclusion or summary, so due to low input cost and easy to handle the hydrodistillation process, the essential oil is most practiced by the fragrance industries. Some thermo-liable terpenes are rearranged due to hot and humid condition in distillation process. So this is a drawback of hydrodistillation, but still it is very practiced due to easy to handle. And the organoleptic oxygenated terpenes are isolated from distillation conditions. So it is no doubt that some of the oxygenated terpenes is miscible or soluble in the process of distillation. But we now just doing some laboratory experiment to absorb this terpenes through resin. To overcome these limitations, so and to improve the yield of this essential oil, so maybe the enzyme assisted process is very economical. So if you're dealing with the high value essential oil which originates from the woody biomass, so due to this cellulosic calcitrant structure. So this oil is not properly leach out. So it takes very long time, and due to this long distillation process, also some of the flower compound also dissipated due to these hot and humid conditions. So it will cut the time. So the oil is also improving, and we also this thermal contact is less. So we are no doubt getting the better quality of oils. Then isolation of a delicious flower fragrance, the liquid CO2 process is most suitable because this is operated at a low temperature and pressure, and for that also the cylinder pressure is sufficient. We do not need any extra pressure, so it is maybe cost economy because we are not using some high pressure pumps, and the loading and unloading system, and this specific the high pressure pumps are very costly in this process. And in the reactor also, if it is the low pressure design, then definitely there is a lot of cost reduction. And similarly, in catalysis process are very stereoselective. So in comparison to simple chemical synthesis, the catalytic process is stereoselective, and it is also known that they are coming under green processes. It can selectively transform the suitable substrate and the target compound of this essential oil to desirable products. Catalysts are used, and therefore processes are called greener, and we use the same catalyst for number of batches. Value addition is required for better return to farmers, and they also create employment opportunity, and particularly for rural employment. And a heterogeneous catalytic and a lipase-based transformation is feasible for esterification to increase the value of essential oils. And for this distillation waste, the distillation waste is used for the production of chemicals for different applications. So presently we only work on how to synthesize this hydroxymethyl furfural, which is the major platform chemical to derive a number of chemicals for food flavor and some cosmetic applications. Distillation waste also used for production of fatty acids using yeast culture. So in coming last years only we get a very prominent result how to use the distillation waste for biotransference to fatty acids. This oil is composed of unsaturated fatty acids, which is most suitable for transformation to lactone-derived flavors. Now, though biotransformations, the unsaturated fatty acids and the ricinoleic acid are used for the production of enantiomer-specific plus lactones for use as a nature identical flavors. So, only by biotransformation process, we only produce the plus lactones. So, and when you select the chemical synthesis, it gives the enantiomer mixtures. And finally, this is the end of my topic. I thank you to all, and particularly I thank the Chemical Engineering Department of SBNIT for giving me a platform to present my work. And I especially thankful to um, I especially thankful to Madam Parekh for giving me and facilitating me the project when he was in the ACRBDST. So thank you, ma'am. And I also very thankful to my friends like Dr. Meghal, Dr. Giriraj, and Dr. Sanjay. They are sometimes interact me for some research platforms. So I thank you all the participants, and thank you all, and thank you, ma'am. Okay,
Most
Dr. Giriraj.
Okay, so participants, now you can pose your questions if any. You can directly ask or you can write in chat box. Okay, Dr. Prasan, there is one question. Is there any raw material requirement in future? I think it's incomplete. Jamin, can you ask directly? Jamin?
Yes, sir. Good
Directly
morning
ask
to all
the
of
question. Yeah.
Yeah, very good morning.
Yes, sir. Is there any raw material requirement like means are you commercializing the technology?
Yeah, actually, right now there is no commercialization. So actually, some some industry in the line, but still for taking this IPR also taking a lot of time. So most of the things in our IPR form. So we have also not uh, we are not approach the industry to take this technology, but few industry are like this technology like this. So right now there is no this technology transfer.
Okay, sir. Because I asked this question because I am working on a farming field, so it
Okay.
is better to guide the farmer to grow such type of plant for future. That's
Yeah,
why.
actually for a little interventions, we also advise farmers you are do these things. So people, farmers are preparing like hand sanitizers, like phenyl, and some cosmetic application. Because though our institute is working on this area, and we have the product development department, and we have the also marketing division also, and we all the scientists also assigned to different states for this cultivation. Because in aroma missions, we are last 3 years we promoted more than 6,000 hectares. So initially also there is a huge cultivation like 20,000 hectares like this, and we add on the 6,000 hectares. And in second phase also there is a task to increase this increase again in 20,000 hectares. So there is a huge cultivation. So when we are going to farmers field and in the cultivation side, we also advise farmers, okay, in this distillation water, you will do this product, you will do this type of thing, so that you get some additional income, and farmers are doing it. But in technology transfer level, we are not transfer this technology, particularly whatever I presented is not transferred till date.
Okay, sir. Thank you so much.
Prashant, one more is that what is the criteria of selecting deep eutectic solvent for the conversion of cellulose to HMF?
No, actually, for this, already some processes are available. Suppose in case of DMA, LIC, lithium chloride, it is a well-known solvent, and it is published in a good journal also. Like ACS also published this work. But the main thing is when we will start working on this, we found that this solvent uh, giving the good conversion. So because of this lithium DM and lithium chloride, it is also behave like an ionic liquid solvent, because this Li and Cl in the ionic form. So that when this ionic forms, and particularly when this chloride ion is available, then only it can solubilize the cellulose. Just like our ionic liquid, like all the ionic liquids we have tried, only chloro related ionic liquid give the solubility of cellulose, because it is a very brittle structure of cellulose. So when to make the cellulose solution is very difficult. So these two are the ideal solvent. To overcome these things, then we think, okay, if we are taking the this choline chloride and citric acid, this choline chloride gives the chlorine presence, and like citric acid, it will combine together, and we make the utility solvent. Then is it soluble the cellulose? Then we found that, okay, yes, it is also soluble the cellulose. This is the main concept, and I think that in compared to other two, it is the cheaper process, and some literature also just report that this choline chloride and citric acid also bio-based chemicals. So to make this process greener and cheaper and give easy solutions, so we select this ETEC solvent.
So, okay, one of the participants would like to know how the mosquito repellent activity is checked. Okay, what is the
Yeah.
procedure to check the mosquito repellent activity?
So actually for this mosquito repellent activity, so in your CMAP also there is a this they also they having the net house also, in which they keep the mosquitoes. So some other scientists are working on this. So we just give them product, and they in this they make this repellent. Suppose what is the repulsion of mosquito per hour like this. So they having the different type of models. And similarly, the same work also we are in collaboratively working in the malaria research institute Delhi also. They have been doing some preliminary experiment, and due to this COVID, they are not giving the complete report, and it is showing the good mosquito repellent activity. So though I am chemistry, I am not exactly telling how they are doing the experiment, but I also see some of the experiment they are making this net house, and they also calculate, okay, how many mosquito is sitting in this place or not sitting. So accordingly, they make some strategies and give okay in comparison to control one, it is giving the better activity. Suppose what are the DT is nowadays already commercialized. Doing the good business. So against DET, against some other compound also, they tested okay. As per DET, this repellence activity is very close to the DET, and they told that okay, this is even a very good mosquito repellent activity in this particular concentration or dose. And then we have the product development department also. So if it is suppose now they are cross checking okay how it is going in the formulations. Suppose they are making some skin formulations as a gel forms, as a spray forms, and as a lotion forms. And sometimes also we have in the very huge agarbatti activity also. So how to use the waste biomass, waste flour to make the agarbatti and the mosquito repellent agarbatti. So if it is one complete laboratory data will generate, then they will go for the different product applications in different type of form.
Okay, so we'll taking the last question. How stereoselectivity of catalyst used in your process affects the output amount?
Yeah, actually, stereo selectivity is very important. Suppose when something is marketed, or something is tested. So, suppose in case of menthol, if it is only minus menthol, then people think that it is the natural one because natural synthesis only one specific one. And similarly, we try to make some stereo catalyst so that whatever the particular image we want, it should be synthesized this product. So particularly this thing is not controlled by the chemical synthesis. So only catalytic process, it is very possible that we are only selecting a single specific isomers. And if it is getting some trace amount of other impurities by using some extraction process or by using some other little bit chemical synthesis process also, we can spin out the other isomers. Only specific isomers we can isolate it. So for commercial aspect, this stereo specific is very important for getting the higher value because chemical product having the value, but as I shown in case of your chemical synthesis, delta gamma decalectron, it is $180, and it is natural one, biotraction one, it is 300 USD. So definitely, just like your general farming, organic farming, so there is two concept and two having the different benchmark. Similarly, if your product is chiral specific, this product having the different benchmark in comparison to the other marketed products.
Okay, so I think someone here has put, so this will be probably the last question. Okay, so how you quantify the major metabolites of the essential oils? Is it relative quantification or there is any other method to do exact quantification?
Particularly for essential oil, we are doing this GC analysis or the DCMS analysis. So, because in case of GC analysis of essential oil, so mostly the volatile is coming along with the water. So there is no chance of non-volatility. Suppose if you prepare any concrete or any solvent extracted products, so definitely the absolute contribution is required. But for this essential oil, so though all the compounds are only water volatile, so almost all the compounds are leaked out from the columns. So only GC analysis is sufficient to check the and monitor the quality.
Okay, so thank you, Dr. Prasant, for throwing some light on the steps of transformation of different chemical compounds. And we hope that these steps of technologies are finally being transferred, and some of the entrepreneurs will take these technologies so that it will really be helpful to the farmers who are involved in the cultivation of these types of aromatic crops. As it is also the mission set by our Honorable Prime Minister to double the farming income. So it will be a very really helpful type of technology. So I am again thanking you on behalf of all our coordinators of this FDP for sparing your time and sharing your experience, your research experience. Okay, thank you, Dr.
Yeah, thank
Prasad.
you. Yeah, thank you, Dr. Girish. So actually, main thing is this honorable Prime Minister started this program of Aroma Mission because they insist all suppose in particular lab, at the medicinal and aromatic plants lab, they told that okay, you if you have number of varieties, why it is not reaching to the farmers and the variety those people are require this. So for this we started this automation, and when it is started, then the next question comes how to make the valuation, because when there is a plenty of oil produced, then our director instead you make some program to make this thing to make valuable products. So that only last 3 to 4 years we have planned this type of work and achieve some this target lines. So the next thing is for commercialization. So then I thankful to all my friends and to Jigisha madam also, and for giving the facility for some projects also. So for that we start this program and make some contributions. Okay, thank you all.
Okay, thank
Thank
you.
you, Dr. Raut.
Yeah, good morning, ma'am.
Yeah, yeah. I'm listening.
Yeah, very,
Thank you very much. Yeah.
my pleasure. You are also here, so I thank you.
Yeah.